ग्रीडी एल्गोरिथम्स की टेक्निक जो है वो बहुत सिंपल है, जिसमें जो प्रीफिक्स है, जो ऑलरेडी ऑर्डर्ड एलिमेंट्स होते हैं, उसको हम इंक्रीज करते जाते हैं अनटिल के जो सारे एलिमेंट्स हैं वो ऑर्डर्ड फॉर्म में ना आ जाएं। और यही टेक्निक जो है एक गेम जो चेस होती है उसमें यूज़ की जाती है। और जो चेस के प्लेयर्स हैं वो इस टेक्निक को समझते हैं और अक्सर वो ग्रीड यानी एल्गोरिथम को यूज़ करके गलत डिसीजंस पे पहुंच जाते हैं। लेकिन जो चेस प्लेयर्स इस ग्रीडी एल्गोरिथम को समझते हैं वो बहुत ही वाइज डिसीजन लेते हैं। जैसे फॉर एग्जांपल उसके अंदर जो है वो क्वीन जो सबसे इम्पोर्टेंट प्लेयर होती है उस गेम की, उसको वो ट्रैप करने की कोशिश करते हैं। लेकिन जो इससे भी अच्छे प्लेयर्स होते हैं वो क्वीन की बजाय जो उसके प्लेसेस हैं जहाँ पे वो पड़ी होती हैं, उनकी बाकी जो एलिमेंट्स हैं चेस के, उनको डिटरमिन करने की कोशिश करते हैं। और उससे जो है वो ग्रीडी एल्गोरिथम्स को यूज़ करके वो ऐसी स्टेज पे पहुंच जाते हैं जिससे वो चेस की गेम को बहुत इजीली समझ के और उसको विन करने की पोजीशन में आ जाते हैं। इसी तरह जो है वो हम देखेंगे कि जो ग्रीडी एल्गोरिथम्स हैं इनको हम कैसे आगे यूज़ कर सकते हैं और जो है वो बिल्कुल राइट डिसीजंस हम उसको यूज़ करके ले सकते हैं। तो यहाँ पे हम देखेंगे तो जो प्रॉब्लम है सिंपल रिवर्सल सॉर्ट एल्गोरिथम का वो ये है कि ये प्रीफिक्स पाई जो है वो एक मेजर है हमारी प्रोग्रेस का and does not accurately reflect how difficult it is to sort permutation. And we cannot rely on this simple reversal sort algorithm. And we also see here that we will define some breakpoints that can be viewed as bottlenecks for sorting the reversals. And using the numbers of breakpoints we will see in detail rather than the prefix that we have already seen that we can increase the size of prefix to sort the different elements as the basis of greedy algorithms that leads to a better algorithm for sorting by reversals. So it will be convenient for us to extend the permutation. So here we can see that this is pi 1 and it will go up to pi n. By pi 0 is not. So it means that we can extend this pi 1 to pi n and we can add a pi naught before pi 1. So it will come before pi 1 and it will be pi naught and its value will be 0. And we can also add pi n plus 1 because we know that this pi n is the last element of this range and we can add n plus 1. If it is 6 then we add 1, it will become 7. For example, if it is 10 and it's 10 we can add 1, it will become 11. So we can extend the pi in both directions. One is pi naught here and pi n plus 1 after pi n, and these will be at the both ends of these elements. So to be clear, we do not move pi naught or pi n plus 1 during the process of sorting. We have seen earlier that we have sorted all the elements present from pi 1 to pi n, but if we will add pi naught and pi n plus 1, then we will not sort pi naught and n plus 1 and we will sort the elements that is present in between pi naught and pi n plus 1. So we call a pair of neighboring elements pi I and pi I plus 1 for which 0 is less than or equal to I and I should be less than or equal to n, and we can call it adjacency if pi I and pi I plus 1 are consecutive numbers. For example, if we have this type of elements 2, 3, 6, 7, so we can see here that 2 and 3, they are the consecutive numbers, and we can call them as adjacency. And similarly 6 and 7, they are also adjacent number, and we can call also them adjacency. And for example, if they are not the adjacent numbers, we have 3, 5, and then we have 7 and 9. We can see here 3 and 5, they are not consecutive numbers. After 3 it should be 4 if it should be a consecutive number, but here it is 5. So we can say that these 3 and 5, they are not adjacency, but they are called breakpoints. Similarly 5 and 7, they are not consecutive, so we can say that 5 and 7, they are breakpoints. And similarly we can see here also in this example 2, 3 are adjacency, 6, 7 are adjacency, but we can see here 3 and 6, they are not the consecutive numbers. So in this case also 3 and 6, they are breakpoints. So we can see the example here 2, 1, 3, 4, 5, 8, 7 and 6. So these are the elements that are from pi 1 to pi n, and we have added pi naught here in this case and pi n plus 1 in this case at both ends. So we have different adjacencies, we have breakpoints, and we have strips in this example. We already know that adjacency is if we have the consecutive numbers, just like 1 and 2, they are adjacencies. Breakpoints means here, breakpoint is, first example is 1 and 3 because they are not consecutive numbers. And strips are the consecutive numbers more than 2. So it means that here we can see 6, 7 and 8, it is in a group form, consecutive. So we can say that this group is a strip. Similarly 3, 4 and 5, they are consecutive and in a group, so this is the second strip. So we can see here in this case 0, 2, 1, 3, 5, 8 and 6, 9, they are non-consecutive numbers. It means these are the breakpoints, and these breakpoints, they can demarcate the boundaries of strips. So we can see clearly here that breakpoints, these are the boundaries of strips. We can see here 0, 2, we can see this is the one strip, and 0, 2 is the non-consecutive and it constitutes the 0, 2, and this is the boundary. And second boundary is 1 of the first strip and 3 of the second strip. So these are the boundaries, and 1, 3 is the second breakpoint. And similarly we can see 5, 8 boundaries, 6, 9 boundaries.